Welcome to the Point One Freestyle. This is a picture of the Sacramento Delta, which you may have heard of that phrase. It's in the news sometimes where a weather reporter will say, oh, the Delta breeze is coming in and bringing us some cooler weather. I have taken a snapshot also of Google Maps to show you that down here, oops, I must have clipped this off as Stockton. Up there is Sacramento. This is the San Joaquin River, and that is the Sacramento River. And right here is where the delta is. I mention that because delta is an important vocabulary word in calculus. It means change. So this is the Greek word for change. And that is going to be the main topic of what we are going to be studying over the course of this year, how things are changing. I will use the symbol from time to time, especially in the slope formula. And there it is. Now, I also like to mention a little bit more vocabulary. Sub is Latin, not Greek, Latin for under. And so when I say something is sub, it means it is under. Now that I've mentioned the slope formula, slope, hopefully you'll remember the letter we tend to use is M. You might see as we move forward that I write that formula as delta y over delta x, which means the change in y values is calculated from the n value being having the beginning value subtracted from it, and the end x value having the beginning x value subtracted from it. And so you've seen that version of the formula. You have not seen this one. This is the calculus version where I say the change in y over the change in x. And I'd like you, please, when you're saying this out loud, to say y sub 1. Because I'm a computer programmer and that's how we say it. You may hear other mathematicians, math teachers say y1, but because I come from computer science, in order for me to understand you, I'm going to ask very carefully for you to say y sub 1. Sorry, arrow is pointing to the wrong place. Y sub 1. This is y sub 2, this is x sub 2, and this is x sub 1. So that'll likely be an entrance ticket for you at some point. You might want to practice saying it out loud. And one other thing I'll mention is that, remember, this is the second point that you have been given, and this is the first point that you have been given. And it's very important that you keep them in the proper order in order for you to get the proper sign, positive or negative. If you flip-flop the top or the bottom without flip-flopping the other, you can run into trouble. So we'll do some examples of those in the actual lecture notes. Now, as far as horizontal and vertical lines go, I'd like very quickly to swap over to a piece of graph paper here and draw a little graph. And I'll mention that I believe that if I talk about this point, you know that this point is 1, 1. And then if I talk about this point, that you know that this point is, 2, 1. And that this point here is 3, 1. You might have heard me pause for a moment to think about, well, which number changes? Is it the first number or the second number as I move along this line? Well, it turns out that the x value is the only thing that is changing. This is why we say that the equation of this purple line is y equals 1. Because it was 1 here, it was 1 here, and it was 1 here. Also, let me mention that the slope of this line is that m equals 0. Because if I take 1 and I subtract 1, I'm going to get 0. And 0 divided by anything is 0. So if I'm thinking about somebody running across this line, they're not going up, they're not going down. That is a no change kind of slope. Now, what if I did start to have a slope that did have some changes in it. For example, what if I graphed this point right here and I said this point is negative 1, 1, but then I'm going to start going up instead of just going out. And this would still be an x value of negative 1, but I've gone up to a height of 2. And what about here? I am still at x equals negative 1, but I am going up to a height of 3. This line must have a different sort of equation, and its equation is going to be all about those x values, because those x values, none of them changed. They were always the same. It was the y values that were changing as I went up or as I go down. So if I think about the slope of this line, it being vertical, on top, when I do, 3 minus 2 or 3 minus 1, whatever, I'm going to get a number. But on bottom, if I take a negative 1 and I subtract a negative 1, if I subtract a negative 1, let's see, I'll show you. On top, I say I get 3 minus a 2. But on bottom, if I take a negative 1 and I subtract a negative 1, then they turn positive. And on bottom, I have division by 0. And we know the division by 0 is bad. So the slope is m is undefined. Okay? Now, when I want to go over these in general, then I will say that a vertical line has an equation, and that equation in general, this particular pink line we found was x equals negative 1, but anytime I have a vertical line, it will be x equals some number. And if I have a horizontal line, its equation will be that y equals some number. And again, it's important for you to remember slope of horizontal is m equals 0, and slope of vertical is undefined. And I say it's important to remember because it's on my little cheat sheet about linear equations. So we've talked about slope formula, we've talked about this, and we've talked about that. And I'd like to move on to reminding you a little bit about slope-intercept form and standard form. Now, when I look at slope-intercept form, hopefully you remember that m is the slope and that b is the y-intercept. And that was our favorite form. We're going to put a big happy face right there because everybody loves it when it's in slope-intercept form. It's easy to graph. It's easy to see what the slope is. Standard form, on the other hand, is kind of like a like I don't even know if I remember that. Okay, that's probably true. You might not remember much about it at all. In fact, let me pose to you a question that you might have had on a test, okay, where it says, what is the slope of 3x minus 2y equals, I don't know, why not 11? You'd be like, oh, I don't really remember what I had to do here. Let me remind you. Do you remember? I'm going to zoom in on this. Do you remember that we might minus 3x from both sides? Like, maybe. Negative 2y is the only thing that's left on that side, so I'm bringing it down. There's my equal sign. I always like to write these in the proper order. I want to put the slope, or the thing that's, going to be the slope, in front. I want to put the thing that is the y-intercept in the back. Like, oh, you know what? This does feel familiar. Okay, I'm going to divide by negative 2. I'm going to divide by negative 2. Whoops. What's that? How did I get there? Negative 2, negative 2. Oh, is this starting to come, back to your mind? Yes, I do remember. Hold on. We might have called it, your teachers might have said, this is called solving for y. Now, why would you solve for y? Usually, so you could find the slope. Here is my slope. Negative 3 divided by negative 2 is the same thing as 3 halves, which I know is 1.5, but I'm not worried about decimals versus fractions here. You can always leave it as an improper fraction. That's fine with me. In fact, I'm just going to call the y-intercept negative 11 halves as well, because my question wants to know what is the slope. And I found that. There it is. In this position, right? Y equals mx plus b. If you can find the number, right there, which I can right here, then you can see what the slope is. M equals 3/2. But I find this work a little bit tedious. I won't lie. I do usually do it though. I usually do every single one of these steps in order to find what the slope is. You're like, well, is there some other way that you could do this? Indeed there is. I will tell you that I'm going to show you a little trick with standard form where I am going to solve for y. Okay, ready? I'm going to take ax plus by equals c, and I'm going to minus ax from both sides. You're like, oh my gosh, too many letters. Why are you doing this? Hold on a second. Let me get all the way through it, and you tell me what you think. I'm reorganizing this so that the x term is in front. And I'm going to solve for y by dividing by that coefficient. Here we go. Y equals negative a over b times x plus c over b. You're like, oh, that was painful. Why would you do that? Well, look, I just came up with a trick. What trick? What do you mean? Well, if you have an equation, which we do up here, I'll write it right here, 3x plus 2y equals 11, and you can say that this is a, and you can say that this is b. Well, if you put it into this form, that the slope equals negative a over b, negative a. Well, a was 3, so I must have a negative 3. And b, sorry, I wrote it down correctly. It's a negative 2y. So that means that b is a negative 2, and I will plug that in. Okay, negative 3 divided by negative 2 is, wait a minute, look at that. 3 divided by 2. I found the slope, and I did not have to go through any of this. Now, if you like this method and you find it very easy, great, stick with it. Trust me, that's the one that I do. But now that I've gone through this method, there are some students who are going to use it as a cute little trick so they can find slopes in their head. So here's another question. Ready? Find the slope of 5x plus 8y equals 16. Okay, well, if you can say that this is A, and you could say that this is B, and you can memorize that M is negative A over B, then you throw A in, you throw B in, and boom, you have the slope, and you didn't have to do any work. I myself can't keep the trick memorized, so please don't feel bad if you also have hard time keeping it memorized. I do have it as an extra credit piece on a quiz, okay? So if you can memorize that formula from standard form, that would be extra credit, all right? Now, let me go over one last thing, and that's about intercepts. X and Y intercepts. I'm going to say and Y intercepts. If I want to look at the intercepts of a line, remember that visually you should be able to identify them. If I had this line here, if I have this line here, and it goes through these 2 points, and I have graphed it, and it's very easy for you to see that this point is 0, 3, and that this point is 2, 0. Then you should be able to tell me that this one is the y-intercept and that this one is the x-intercept. But what if I gave you an equation? You're like, oh, you don't want to have to graph that, right? What is the x and y intercepts of, ready? Let's do some different numbers here. 4x minus 5y, and that equals 20. And you could tell that I'm picking these numbers. They're easy on purpose. Well, is there a trick for me to do this without graphing? Indeed there is. Because when I do look at the intercept, be it the x-intercept or the y-intercept, one value will always be 0. So for the y-intercept, it's the x value that is 0. And for the x-intercept, it is the y value that is 0. So if I've given an equation, a trick that I could use to finding my intercepts, which is really handy, is this trick right here. Pick a 0, and then find out what happens for the rest of it. So if I say that x is 0, I have 4 times 0 minus 5 times y equals 20. Well, that's 0. Negative 5 times some number is 20. Isn't that number negative 4? How about over here? I say I have 4x minus 5 is multiplied by y, which in this case is 0, and that equals 20. Well, this disappears, and so now I have 4x equals 20. 4 times some number is 20. Isn't that number 5? Very, very easy, simple trick. So you have identified here the x-intercept, and you have identified here the y-intercept.